Welcome to Flashcards Friday on Math Science History. Today is a follow-up from Tuesday's podcast that I had with the Director of Research of the Massachusetts Historical Society, Dr. Kanisorn Wongsrichanalai. He told us all about the inoculations of smallpox during the Revolution, and I highly recommend that you listen to Tuesday's episode. Give it some consideration because it is really eye-opening and enlightening about the power of people banding together to support and advocate for science. As we concluded, he left us listeners with this powerful quote that still sticks with me, and I'm going to share it with you. He said, "Do the math, believe the science, and learn your history." And so I'm going to go into this a little bit more for this Flashcards Friday. But first, a quick word from my advertisers. When you hear numbers, don't let them just wash over you. Test them. In the 1700s, smallpox killed about 30 out of every 100 people who caught it the natural way, meaning who just caught smallpox. That's a 30% fatality rate. And in contrast, people who went through the inoculation process, the deliberate exposure to a small dose of smallpox, faced about a 2 out of 100 chance of dying. That's only 2%. So how do you do the math? Well, you take the two percentages and compare them. Which number is bigger, 30% versus 2%? That's kind of a no-brainer. If you imagine 100 people in a room, inoculation saves 28 more lives than doing nothing. That difference is the reason George Washington inoculated the Continental Army. It's simple arithmetic, but it changed history. But here's how not to do the math. Don't mistake a single story for the whole picture. If one neighbor survived smallpox the natural way, that doesn't mean it's safe for everyone. If one person swears that Tylenol caused a problem in their child, that doesn't make it a proven cause. Anecdotes are powerful, but they don't show probability. Real math requires looking at all the cases, not just one. That's why statistics matter. They protect us from being misled by isolated stories. And the same applies today. Some claim that Tylenol causes autism, but when scientists look at the numbers, billions of safe doses taken over decades and no causal pattern, the math doesn't support the fear. If the numbers don't add up, neither should the claims. Now, let's talk about believing the science. Math gives us the raw numbers. Science tells us what they mean. But here's the challenge. Not every source is trustworthy. So how do you vet science in a world full of noise? Well, first, ask, who is publishing the information? And for the record, Instagram is not a credible source. Okay, so let's look at some other places to validate the science. Peer-reviewed journals, universities, and health organizations like the PHAC, which is the Public Health Agency of Canada, the ECDC, which is the European Center for Disease Prevention and Control, and the World Health Organization, the WHO. They have checks and balances. A random post on social media does not. And sometimes even Fox News and MSNBC get it wrong. So, while headline-driven, click-based news outlets can grab attention, they often oversimplify or exaggerate the science to get more clicks. If you want to see the source for yourself, use tools like Google Scholar or PubMed or even your local university library's website to find the actual research papers. You don't have to read every word. You can even just read the abstract or the conclusion, but you can see who has published the study, when it was published, and whether it's backed by reputable institutions. Second, look for consensus. One study alone might show a flashy headline, but real science is built on dozens, even hundreds of studies that point in the same direction. For smallpox inoculation, evidence piled up across towns and armies. Mortality rates dropped everywhere inoculation was tried. For Tylenol, studies claiming a link with autism haven't been confirmed by larger research. The consensus is clear. No proven causal connection. And third, look at motives. Does the person stand to profit or gain attention by spreading fear? Reliable science does not hide in its data. It invites others to test it. That's the power of science, where we keep running these tests to make sure they are 100% accurate before we roll them out to the public. Finally, let's learn from the past. The path to modern vaccines was not easy. In the 18th century, inoculation was scary. It was frightening. Weeks of isolation, visible scars, and real risks. But the courage to try it led to discoveries like Edward Jenner's vaccination in 1796 using cowpox to safely prevent smallpox. That step forward eventually gave us modern vaccines for measles, polio, COVID, and more. History reminds us that progress doesn't happen overnight. It's built on trial, error, and evidence. Washington's decision to inoculate saved the revolution. It did. Jenner's work saved millions more, and the 20th century global vaccination campaign finally eradicated smallpox from the planet. So, when we hear wild claims today, whether it's about Tylenol, COVID vaccines, or any other health measure, remember our history helps us separate fear from fact. So, let's look at the takeaways. 1, do the math. Don't just listen to the numbers. Work them out for yourself. Statistics show us probability, not certainty. One personal story can be powerful, but it doesn't tell you the odds. Looking at the whole picture does. A practical example is smallpox death rates. 30% without inoculation, 2% with it. That's the math that saved an army. Here's a memorable phrase to remember. One story is a feeling. 100 stories are a statistic. Takeaway number 2, believe the science. Numbers alone can be twisted, but science is the process that checks them. Not all sources are equal. Peer-reviewed studies, medical institutions, and organizations like the PHAC or WHO have guardrails that random blogs and clickbait headlines do not. A practical example, if you want to check the claims, use Google Scholar, PubMed, or university libraries to see who published the research and how often it has been confirmed. If you want a memorable phrase, here's one. Science isn't just one paper. It is the chorus of evidence. And finally, takeaway 3, learn from history. Every health breakthrough we rely on today exists because people before us took risks, tested ideas, and trusted science, trusted the evidence. Inoculation led to vaccination. Vaccination led to eradication. Understanding that journey shows us why modern vaccines work and why trust in science is part of our survival story. Let's look at a practical example. George Washington inoculated his army. Edward Jenner discovered cowpox vaccination. The WHO declared smallpox eradicated in 1980. So, if you want a memorable phrase, here's one. History doesn't just tell us what happened. It tells us why we are alive. Together, the 3 expanded takeaways give listeners not just a slogan, but tools. And we have Dr. Kanisorn Wongsrichanalai from the Massachusetts Historical Society to thank for this one. 1, do the math. Think in probabilities, not anecdotes. 2, believe the science. Vet the source. Look for consensus. And 3, learn your history. See how evidence built our health systems. Thank you for listening to Math Science History's Flashcard Fridays. And until next time, carpe diem.